Hi everyone, welcome back. Let's continue on the session 11.4 cross products. So this example, find all the unit vectors that are orthogonal both this vector and this vector. So let's call this is U, this is V. So we want to find a vector that are orthogonal to both vectors. One choice is to find out the cross products, right? So let's figure out the cross products. So the first row we put I, J, K, and the second row we put the first vector, so that is 3, 5 minus 4, and then we have 2, minus 1, and 7. So we do plus, minus, plus, so plus I, and then the determinant of the submatrix by deleting the first row and the first column. So we have this guy, right? 5 minus 1 minus 4, 7, and then we have minus J. And then by deleting the first row and the second column, so we have 3, 2, minus 4, 7, and then we have plus K, and then by deleting the first row and the last column, so we have the submatrix 3, 2, 5, 1. So far so good, everybody. So this is the determinant of 2 by 2 matrix. We cross multiply, but we subtract. So 5 times 7, subtract minus 1 times minus 4, minus J, 3 times 7, subtract 2 times minus 4. K, 3 times 1, subtract 2 times 5. Okay, so for all this example, I hope you can try the problem first and then continue to play the video and check your answers. Well, here we have 3 negative, so the answer is negative. And then we have minus J, 3 times 7, 21, minus is plus 8. And here we have 3 minus 10. Okay, so that gives us, let's use the component expression. So 5 minus 4 is 31. Then negative 29. 3 minus 10 is minus 7. Oh, you know what? I realized I have a mistake. Where is my mistake? This guy should be minus 1. See, this guy should be minus 1. Then it changed to, this is minus 1, so it become minus 3. Minus 10 is minus 13. Yeah, sometimes a little minus can change our answers. So we gotta be very, very careful. Okay, so we all learn from our mistakes. Okay, so this is a vector that's orthogonal to both of them. Okay, so this is U, this is V, and then this guy is U cross V. Okay, so it's orthogonal to both of them. Then you want to find unit vector. Well, last time, before we talk about how to find a unit vector, there are 2 unit vectors, one in the same direction of the vector, one in the opposite direction of the vector. And in order to find a unit vector, you also want to find you use that vector divided by the length of it, right? So here, what is the length of U cross V? Well, that is the square root of, big numbers, 31 squared, 29 squared, and 13 squared. Okay, I do need my calculator in this case. Okay, so take out your calculator, input. So here I would try to have like exact numbers, so don't give me decimals. So it's okay to leave the square root there, and then so use your calculator to calculate 31 squared plus 29 squared plus 13 squared. What do you get? I got 1971. Okay, then what are the unit vectors? So there are 2 unit vectors. One is this whole vector divided by the length. Okay, so we have 31 over square root of 1971 minus 29 over 1971 minus 13 over square root of 1971, or the opposite direction. So we just flip the sign of each of the components. Okay, so this guy become plus, and this guy become plus. So far, so good, everybody. So now we have found the two vectors that are orthogonal, both u and v. So far, so good. Okay, let's continue. What is the distance from the point P to the line passing through the points A and B? Okay, so here let's draw some picture. We have P here, we have A and B here. We want to find the distance from the point to the line, so we're looking for this distance, okay, from the points to the line passing through A and B. Okay, so here, what can we do? So we can figure out the vector AB, and we can also figure out the vector AP. Then what is this guy? Okay, so this guy is so if we have the magnitude, this is AP, right? Let's say this is theta. Well, then the distance is the magnitude of AP times sine theta. And how do we calculate that? Well, we can multiply by, so we can multiply this guy by AB, and we can divide it by AB. Now, do you realize the top is actually the length of the cross products AP cross AB, and then the denominator is just the length of AB. So this is how we can calculate the distance between a point to a line passing through 2 points. Alright, now let's see, what is AB? So AB is, we use point B, 892 minus point A, 2 minus 1, 5. Well, that equals 8 minus 2 is 6. 9 minus -1 is the same as 9 plus 1, 10. 2 minus 5 is -3. So far, so good, everybody. How about AP? So AP is, we use a point P, 3, 5, -2 minus point A, 2, -1, 5. 3 minus 2 is 1. 5 minus -1, 5 plus 1 is 6. -2 minus 5 is -7. So far, so good, everybody. Alright, and then what do? We compute the cross products. So AP cross AB. So you can also do AB cross AP, because we're looking at the length of it. The answer will be the same. Okay, so this is I, J, K, 6, 10, minus 3, 1, 6, minus 7. Okay, that's I, and we have the minus 6, 10, 6, minus 3, minus 7, minus J, and then 6, 1, minus 3, 7, and K. 6, 10, 1, 6. Is that okay, everybody? So this is the first minor, and then these are the second minors, and then this guy is the last minor. Alright, Well, that is I times, okay, because I don't have much space here, so I'm gonna say it, okay? So 10 times minus 7 is minus 70, minus 6 times 3 is so 6 times negative 3 is minus 18, but minus negative 18 become plus 18. Okay, and then minus j. Here we have 6 times 7 is 42, minus 1 times negative 3, so become plus 3. Okay, are you following? 6 times 6 is 36. Minus 1 times 10 is 10. Okay, so that is minus 70 plus 18 is negative 52. And then, let's see here. And here, I realized that there's a mistake again. You see, it should be minus 7 here. Okay, sorry about the negatives. So this is negative, then it's minus 39, but become plus 39. And then 36 minus 10 is 26. Okay, so next we want to find the length of AP equals AB. Ooh, that is square root of 52 square, 39 square, 26 square. Okay, so use your calculator, and 52 square plus 39 square plus 26 square, the answer is, what is that? 4901. Okay, how about AB? Well, AB is 6 square, 10 square, 3 square. Well, that's 36 plus 100 plus 9. The answer is 145. Okay, finally, our D. Our D is, we use the length of AP equals AB. So 4901 divided by the length of AB, which is 145. Okay, and so you can see there we can simplify it. So it equals square root of 169 over 5. So far, so good, everybody. In this problem, if you don't simplify it, that's totally fine. Okay? Alright, let's continue. So this let's look at this example. This is actually an old example. We have done it, but with another method. So today, we work on this problem using cross products. So let's see what it is. So first, let V be the vector for minus 3 and 2. We want to find all vectors that are both perpendicular to V and parallel to the xy plane. So we have the vector V, and we want to find all the unit vectors that are both perpendicular to V and parallel to the xy plane. What does that mean by saying parallel to the xy plane? So this is the xy plane. Okay, let's look at this vector. So this is the vector k, right? Is perpendicular to the xy plane. And if a vector is parallel to the xy plane, okay, so parallel to the xy plane, it means this vector must be perpendicular to the vector k. Okay, so U must perpendicular to vector K. So now we want to find U that is perpendicular to V, and U is perpendicular to the vector K. Well, and U is a unit vector. So how do we do it? Okay, last example. If we want to find a vector that are perpendicular to both vectors, we look at the cross products, right? So here, we can consider V cross K. So this is I, J, K, okay. So V is 4, negative 3, 2, K is 0, 0, 1. And what is amazing? Okay, let's see here. So this is plus, this is minus, this is plus. So we have I times, this is the determinant of the submatrix negative 3 to 1 minus J, the submatrix of 4, 0 to 1 plus K, the submatrix of 4, negative 3, 0, B, 0. So there is a property of matrix that if it contains a row of entirely the zeros or a column entirely of the zeros, then this guy is 0. Okay, so that's why we have I minus 3 times 1 is minus 3, the minus 0 times 2 is 0. And then minus J times 4 minus 4 times 1 is 4. Subtract 0 times 2 is 0. So that's why we have minus 3 and minus 4. So far so good, everybody? Uh-oh, sorry, I forgot. We are in this space. So there are 3 coordinates. Even the K component is 0, but we cannot miss it. Okay? And then what is the length of this vector? We have square root of 3 square, 4 square, and that's 9 plus 16. That is 25. So that's 5. Okay, you remember the special right angle triangle has sides 3, 4, 5. Okay, now how do we find a unit vector again? We can use that vector over its magnitude. So that's why we have minus 3 over 5, minus 4 over 5, and 0. Or negative of that will give us minus minus become plus, 3 over 5, minus minus become plus, 4 over 5, and this guy is 0. So far so good, everybody. So now we have found 2 unit vectors that are both perpendicular to V and parallel to the xy plane. You can actually check our answer with the previous session. Do we have the same results? So you can check that. All right, let's continue. So let's look at this example. Consider the points P, Q, R. Part A. Find a vector that is orthogonal to the plane containing the points P, Q, R. Okay, how does that work? So here we have a plane and we have P, Q, and R on the plane, right? And so 3 points can give us some vectors, right? We can form the vector PQ and we can form the vector PR. Then now how can you find a vector that is orthogonal to the plane? Well, how can you find a vector that's orthogonal to the PQ and PR? Consider their cross products. So in this problem, we just need to find a vector. So there could be many answers. You can use PQ cross PR, or you can use QR cross PQ, or PQ, or PR cross QR. So a lot of answers to this problem, okay? So what's PQ? Use Q minus P. So Q is minus 1 minus 2, which is minus 3. 3 minus 1, 2. 4 minus 5 is minus 1. Is that okay, everybody? Do you need me to write down the details, or are you fine with that? Okay, I hope you're fine with that. And what is PR? We use the point R, 306 minus P, 215. And then look at each component. 3 minus 2 is 1. 0 minus 1 is minus 1. 6 minus 5 is 1. Right? So far, so good, everybody? And then we can calculate is cross products. So PQ cross PR equals, we have I, J, K, and then we have negative 3, 2, minus 1, and then we have 1, minus 1, and 1. Okay, so plus, minus, plus. Okay, how do we calculate? So don't forget, please, like, before you do each example, pause the video and try to work on the problem first. And after you're done, you can go ahead and play the video and check your answers. So to practice, we do have a lot of examples in each session, so I hope you can practice more, and there are more problems in your homework and in our textbook. Okay, so we have plus I times the determinants of the submatrix 2, minus 1, minus 1, 1. And then we have minus J, the submatrix, minus 3, 1, minus 1, 1. Plus K, we have the submatrix, negative 3, 1, 2, minus 1. Is that okay, everybody? Yes? Alright. Then cross multiply. 2 times 1 is 2, minus negative 1 times negative 1 is 1. J, negative 3 times 1 is negative 3, minus 1 times negative 1 is negative 1, but minus negative 1 become plus 1. K, minus 3 times minus 1 is 3. Minus 1 times 2 is 2. So here we have I, 2 times 1 is 1, minus J times negative 2, plus K, 3 minus 2 is 1. So in the components form, we have 1, negative, negative 2 is 2, and then 1. Very nice number. So that is the vector 1, 2, 1. So far, so good. So for part A, we're done. So we have find a vector that is orthogonal to the plane containing the points PQ, R. Okay. So if the problem asks us to find the unit vector, then you still need to compute the length of this vector and then use this vector to divide it by the length of that. Okay, that will give you one unit vector, and the other unit vector will be negative of your previous unit vector. Alright, let's continue. What is the area of the triangles with the vertex P, Q, and R? Okay, let me draw a picture here. So we have P, Q, and R. Remember, what does the magnitude of the cross product give us? It gives us the area of the parallelogram. Okay, so the area of the parallelogram is the length of the cross products. Okay, we can use cross products of any two sides of the parallelogram, right? And let's see, what's the length of that? Each component squared, and then add them together, then take square roots. So 1, 4, 1 give us 6. So 6 is the area of the parallelogram. And then what is the area of a triangle? So see, a triangle is half of the area of the parallelogram. So 1/2 times square root of 6, square root of 6 over 2 is the area of the triangle PQR. So see, this example actually we make use of the fact that the length of the cross products equals the area of the parallelogram. Okay, so so you might want to ask, what if I use QR and PR? So if you use QR and PR, okay, so QR and PR will give you this parallelogram, but actually they have the same area, right? You simply just cut it this way, and then you put this guy here, or you reflect it here. So far so good, so they will have the same area. So you feel free to use the cross products of other two sides of the triangle PQR. Okay, and you can use PQ or QR, doesn't matter, because the cross products will just differ by a sign. Okay, so that's the direction different by a sign, is in the opposite direction. But for the area, for the magnitude, -1, absolute value of -1 is just 1. So the absolute value, the length of the cross products will be the same. So that is the session 11.4. Have a nice day. Bye.